This is section 1.4, combinations of functions. The idea of this, what we're going to be reviewing in this section is that we're going to have at least two functions, and throughout this entire lesson, I use only two functions, and their names are f and g. Incredibly creative, but we have two functions, f and g, and we're going to combine them. So how can I combine two functions? Well, there are a lot of different ways you can combine functions. Those mathematical operations that you love are some of the ways. So we can add them together, we can subtract them, we can multiply them, and we can divide them. And that's what these first four bullet points are. And what I have written here are two ways of notating two functions added together or subtracted together. And they're both correct. So you can call them f plus g, and it's a function of x. So this is f plus g, the function of x, or the function f of x plus g of x. They're both fine. That's what they mean. The book will use these ones on the left here. And then this fifth way of combining two functions into a new function is an operation that is strictly used with functions, and that is composition or composing. When you compose two functions, you replace the input of one function with the outputs of the other function. So for example, if you have f and this little open circle is the word of, if you have the function f of g of x, then that means you have replaced the inputs of f of x with g of x, with the actual function g of x. So the best way of doing this is to do examples. I've got two functions, f and g. F of x is this quadratic x squared minus x, and g is the line 1 minus x. So we're going to combine these a bunch of different ways. Let me just number these. 1, 2, 3, 4. So 1, 2, 3, and 4 are the basic operations: addition, subtraction, multiplying, and dividing. Then we're going to do 4 different ways of composing them, of plugging one into the other. And we're even going to plug one into itself. Kind of neat. Okay, so first of all, what if I add the two functions together and obtain f plus g of x? That is simply x squared minus x plus 1 minus x, and this simplifies to x squared minus 2x plus 1. Now, on the second example, what about f minus g? I'm going to take one function and subtract the other function. This is also simple as long as you remember the very important thing of distributing the negative. We subtract the entirety of g of x, all of g of x, not just its first term. Every term of g of x gets subtracted. So my minus x is canceled because I have a minus x minus a minus x. Okay, next we're going to multiply them together. What is f times g of x? Notice this is a times dot, not an open dot that's a composition, but a small dot that's multiplied. So that would be x squared minus x times 1 minus x. And we need to distribute and collect like terms. So first I'll distribute the x squared. Now I'm going to distribute the minus x. And then I collect like terms. I get negative x cubed plus 2x squared minus x. You don't need to factor that. And then the last one, I asked you to find f divided by g. So f of x divided by g of x. Let me write it the way the book would write it. They would write this as the function f divided by g of x. So that is going to be x squared minus x divided by 1 minus x. I'm going to show you how this simplifies. Some of us get a little bit too happy with canceling, and we cancel things we shouldn't cancel. Right now, you may not cancel a thing, and that's because you don't have anybody multiplied in there to cancel. You only have subtraction happening. But in the top, I can factor out an x, and if I do that, I get x minus 1. And that is so close to crossing off the 1 minus x on the bottom, but it doesn't. They're not quite the same. They would be if these were pluses, because a plus b is the same as b plus a, but with minuses, a minus b is not the same as b minus a. So how can I fix this? Well, I could have, instead of just factoring out an x, I should have factored out a negative x. That would give me negative x plus 1. Now in this case, negative x plus 1 is the same as 1 minus x. That is the same as 1 minus x. And so now that I have 1 minus x multiplied on the top, that can cancel with the 1 minus x on the bottom. And so this is just negative x. All right, those were our first four. Now let's do our compositions. I have lost my functions, so I'm going to pull them down here so I can see them. Okay, so our first one, I don't know if that, I'm going to do f of g. Some of us call this fog. F of g of x. So now g of x is going to be the input of f of x. So instead of x's in f, I'm going to put g. So I don't have x squared minus x. I have 1 minus x squared minus 1 minus x. And then I'm going to simplify this. I foiled in my head. And so this is x squared minus x. That's how that simplifies. Interesting. That's f. That's random. Okay, 6. What is g of f of x? G of f of x. Well, now f, the x squared minus x, is going to be my input. So I'm going to stick that into the x and g. So I don't have 1 minus x anymore. I have 1 minus x squared minus x. Be sure to distribute negatives. This is negative x squared plus x plus 1. The next thing I'm going to find is GOG, g of g of x. And so now I take the x and g, which was 1 minus x, or which was x and 1 minus. So here's g. I'm going to replace this x and this x with the function g, which is 1 minus x. So I don't have 1 minus x anymore. I have 1 minus 1 minus x. And this simplifies to x. And then finally, we're going to find f of x. And so f is the function x squared minus x squared minus x, or input squared minus input. But now my new input is f, which is x squared minus x. So I have x squared minus x squared minus x squared minus x. And I have to FOIL this first x squared minus x. I will not do that in my head. Now I've distributed that negative. This is going to be x to the 4th, and then I'll have x cubed 2 times, one from the outside and one from the inside. So that's a 2x cubed plus x squared. And so this simplifies to x to the 4th minus 2x cubed plus x. The x squared is canceled. All right. All possible ways of combining those two functions is what we just did. All right, next example. I'm only going to do the first 4, the plusing, the minusing, the timesing, and the dividing, but we're going to add finding domains, because finding domains is a little tricky, especially when you do fog and goth, but I don't have that on here. I might put that on there. Okay, so I'm going to start with the domain of f. Before I do any composing, I'm going to worry about, or before I do any combining, I'm going to worry about their initial domains to start with. F has a very restricted domain, because this square root, x squared minus 1, is what I'm taking the square root of. That has to be greater than or equal to 0. That's kind of tricky to do. How do I make x squared minus 1 always greater than or equal to 0? Well, to do that, I'm gonna graph it and show you where it's always greater than or equal to 0. So the x squared is a parabola, and minus 1 shifts it down 1. It's going to have zeros of 1 and negative 1. And so this is the graph of x squared minus 1. And I want that graph to be positive. When is a graph positive? The graph is positive at the parts where it's above the x-axis, where the y values are positive. And so that I've highlighted in red here. So x squared minus 1 is greater than 0 in these two branches here. Okay, so this first branch on the left, if I write this in inequality notation, this is when x is less than or equal to negative 1. And over here, this is when x is greater than or equal to 1. And that's my domain for f. So the domain is, I'm going to write it in interval notation, negative infinity to negative 1, and 1 to infinity. G has a much easier domain. It's also a square root, but here x only has to be greater than or equal to 0. And so this domain is 0 to infinity. 0 to infinity. Okay, so what happens when I add f and g? What changes with the domain? Well, if I couldn't use a number in f, then I can't use it in f plus g. And if I couldn't use a number in g, then I cannot use it in f plus g. And so you combine their domains to the most restrictive domain, and that's the domain for everything. It's kind of like two parents and an offspring. If f is the father and g is the mother, and f has certain rules and g has certain rules, you have to follow both sets of rules. So that means following all the rules for f plus g. All right, so these don't add together very pretty at all. It's just x squared minus 1 plus square root of x. But the domains, how do these two domains add? Let me draw you a picture. So there's -1, there's 0, and there's 1. So let's make f in red. The domain of f is that I can use this part and this part. That's where you're allowed to go, only in the red part. But then G, let me do that in blue. G says, well, no, you can go in this part, and only this part. So if one parent only wants you to stay in the red zone, and the other parent only wants you to stay in the blue zone, then you really have to stay in the purple zone, in the red plus blue zone. So where is that? That would be here, where they both overlap. And so the domain of f plus g is that x has to be greater than or equal to 1. Or this is 1 to infinity. Okay. Now, f minus g is very much the same, only there's a minus sign. So f minus g of x, I'm going to put that over here. That's just square root of x squared minus 1 minus square root of x. And it has the same parents, so it has the same domain, that x has to be greater than or equal to 1. F times g. When we do f times g of x, we're going to multiply square root of x squared minus 1 times square root of x. Now this will simplify. You can just use one square root as long as that's a times. And then you can distribute the x. Most of us don't feel like to distribute backwards, but that's how it distributes. Now you don't have to worry about the domain of this. You just have to worry about combining the domain of the two originals, just like we did before. And so it's, again, that purple area of 1 to infinity. Because it doesn't even matter if this domain of this final function is more inclusive. Like they say, no, you can go at other parts too. It doesn't matter. If the original two are restricted to that much, then that's how much we have to restrict to, at least. And then the last one was dividing. Now this is going to be a little bit different. So let's look at f divided by g of x. So this is square root of x squared minus 1 divided by square root of x. Now I've suddenly introduced division, and that's a whole new rule. This doesn't really simplify. You can think of it as 1 square root if you'd like, but those are the same level of complexity. So now, if you look at your final result, we have a different kind of scenario than what we had before. So let me do my number line diagram as before. -1, 0, and 1. So we've got mom or father, I think F was father, who says you can go in the red zone. And then we've got mom who says, oh, I guess never mind, this isn't really, who says you can go in the blue zone. And so we decided that really means purple here. Okay. So now we have a kid, and maybe this kid is hard on themselves. And they've got their own set of rules. And one of those rules should be not to divide by 0. And so this kid does not want you to use 0. Because if x equals 0, then I would divide by 0. But it's in the purple, we don't go over the number 0 anyway. And so this domain, let me show you where this would matter. This domain is still 1 to infinity. Let's do g over f. That's the one that would matter. If we did g over f, then that would be square root of x over x squared minus 1. And so now if I draw this picture, of my domain, I've got the square root of x squared minus 1 father, who says nothing between -1 and 1, then you take the square root of a negative, and then the square root of x mom, who says nothing negative, because then I'd take the square root of a negative, and now you've got this kid who's got a denominator of x squared minus 1, and they say no -1 and no 1, because then I would divide by 0, right? X squared minus 1 should not be allowed to be 0, because then I would divide by 0. You're not allowed to divide by 0. And so now the way that this adds up is 1 to infinity, but not 1. So the real domain here is 1 to infinity, no longer allowing you to use 1. And compositions work that way too. You have to look at the final answer, and you might get more restrictive even in your domain. So your domain only restricts more and more. You have to look at your original two functions and then see if you, once you combine them, see if you need to restrict even more. Okay, last example. We're going to go backwards. This is a really interesting type of scenario, and it's really kind of difficult to think this way, but it's also really important to be able to think this way. We do something like this in calculus. So in this example, I am showing you the result of combining two functions. And now the question is, what were the two original functions? What were f and g? What was f, what was g? So what was f of x and what was g of x if, when I plugged g into f, I got 2 divided by x squared minus 3? Now, I know the answer to this and I can see it, but I want you to muddle through this and think about it a little bit. There is more than one right answer, which is kind of exciting. So there's more than one right answer. See if you can get an answer, first of all, because just getting an answer is difficult. But see if you can get more than one, because there's more than one right answer. And then make sure you have that included in your notes.